there! We have seen already how to calculate the gradient, but what does it mean? If I have the gradient in this graph, for example, from this point to this point, how do I interpret it? In other words, how do I give it a meaning in the real world? Well, that's what we're going to look at today. I have a graph here. It's the graph on the vertical axis. I have the weight of a particular baby in grams. And on the horizontal axis, I have the age of the baby in days. So when the baby was 10 days old, the baby was 4.15 kilos, or 4,150 grams. In fact, this isn't just any graph. This is my baby. This is the weight of my baby in the first couple of weeks. And there was a very terrifying part right here that we'll look at in a moment when we interpret the gradient, when we give it a meaning. Before we give it a meaning, let's figure out what the gradient actually is as a number, from this point here all the way down to this point here, point B. To do that, we will use our good old friend, the gradient formula. Slope, m, or gradient, is the y-coordinate of the second point. Take the y-coordinate of the first point divided by the x-coordinate of the second point. Take the x-coordinate of the first point. What does that look like? Well, let's do it one at a time. We'll put the fraction bar in. The y-coordinate of the second point, well, the second point is b. The y-coordinate is 4,100. And the y-coordinate of the first point is, y-coordinate of this point is 4,400. So you can see the y value has gone down. It was 4,100, went down to 4,400. What about on the horizontal axis? The x-coordinate of the second point is 4, and the x-coordinate of the first point, we'll go down to look at the x-coordinate here, is 0. So we've filled in, the x and y for both points. Now we can simplify this fraction. On the top, 4,100 take 4,400 is negative 300, and on the bottom, 4 take 0 is just 4. We can simplify this further because 300 divided by 4 is 75. And a negative and a positive make a negative. So the gradient is negative 75. Great, we've done a little bit of maths, but what does that tell us? Does that tell us anything? What does Mr. Aneri do with this knowledge when he knows that this is his baby? Well, we can interpret the gradient. We can give it a meaning. The gradient or the slope is negative. So is it going up or down? Down, because the gradient is negative. I mean, you can even see that from the graph, right? It's going down. And it's going down, if we look at the unit, the top part here, the top of the fraction, the y-axis, these numbers are in grams. And the x-axis is in days. So when we say it's going down by 75, it is going down by 75 grams per day. In other words, the baby is losing 75 grams of weight per day, which I can tell you at the moment was terrifying, but totally normal for babies in the first week. Whew. Do you see how I got the unit here? Grams per day. It's the unit at the top, in other words, the unit on this axis, divided by the unit of the bottom here, the unit on the x-axis. We'll do a few more interpreting graphs, but I won't make you calculate the gradient for these. I've already figured it out for you. Here I have a graph of the amount of water in litres and the amount of time in hours. This graph might represent a container filling up with water. It starts with 0 litres in it, it starts empty, and then after 1 hour, there are 2 litres in it, after 2 hours, there are 4 litres in it, and so on. You can actually see that the gradient is 2, because for every 1 increase in time, the y-axis goes up 2. So that's why the gradient is 2. For each square we go across, we go up 2. To interpret this gradient, we can say, well, the container is filling up with water because it's increasing, and it's filling up at a rate of 2, the gradient is 2, litres per hour. Where did this unit litres per hour come from? Well, this rate came from the y-axis is litres, the x-axis is hours, so the unit is litres per hour. Even before looking at anything else in this question, you can already see the unit for the gradient is going to be kilometres per minute. It's like a speed. In fact, it is a rate. So the unit for the gradient will always be the unit of the y-axis divided by the unit of the x-axis. We can have a guess as to what this graph might represent. It says distance from Earth in kilometres, something that might be 5 kilometres above Earth, maybe a plane or an asteroid or something. I'm going to say it's a meteorite falling to Earth, just for an example here, because that seems to fit, I suppose. The gradient is -1. Although the question tells us that, you could figure it out, because if I start here, for example, and I go across 1 unit, I have to go down 1 unit. So for each unit across in the x, the y unit goes down by 1. That's why it's negative. Interpret this gradient. Well, the unit is going to be kilometres per minute, and that sounds like how fast this is happening. So it is falling. The meteorite is falling, going down at a speed of 1 kilometre per minute. Gradients are everywhere, no matter where they appear, always represent a rate, and usually represent how fast something is happening and if it's going up or down. Like right here, the baby's weight was falling, it was losing weight at 75 grams per day, and here the gradient is slightly positive. The baby is putting on weight over time, but at a slower pace. Anyway, I hope that helps you see how to interpret a graph and interpret the gradient of a graph. I will see you guys next time. Bye everyone.